Hello students, today we're going to be looking at more transformations, specifically reflections. Please don't forget to take notes as you go and take the check that follows the video. So before we get into it, just so you know what reflections are, we do them across a line R, that's called a line of reflection, and it has a transformation that has two properties. The first one is if point A is on line R, then the image of A is itself. So what that means is if there was a point on this line right here, and say it was right here, when we did our reflection, it would land exactly in the same exact spot. So A and A prime would be exactly the same. The second one would be if point B is not on line R, then line R is considered the perpendicular bisector of B prime. Now as you can see here, we've connected the points C prime. So it's the same exact idea, and what it means by perpendicular bisector is that this line here, that if we were to connect C and C prime, is perpendicular to our line of reflection, and then these two segments here are going to be exactly congruent. So that's what a perpendicular bisector is, that these two pieces here are congruent to each other, and this is a perpendicular line to our line of reflection. So we have a couple of different types of lines that we can reflect across. Our first one is our x-axis. So the x-axis is our horizontal plane, so this here would be our x-axis, and as you can see, our reflection, kind of like the mirror image, where everything is opposite of each other. This would be an example of your x-axis if you reflect it that way. Our second example is our y-axis, so that is the vertical axis on your coordinate plane. So right here's the y-axis, and as you can see, here's another example of that C prime. They're exact same point, while everything else is equal distance from that line of reflection. So that B and B prime, they're both 2 units away from the line of reflection. The third one we'll have is if x equals a number. Now this tends to get tricky because the x-axis is a horizontal line, but x equals a number is a vertical line going straight up and down. So here's an example of where x is equal to 1. That would be our line, and both of them are an equal distance away from that. The fourth type would be y equals a number. So if x equals a number was a vertical line, y equals a number is a horizontal line. So here's an example of that. Here would be our line of reflection. This is y is equal to 1. Again, just because the y-axis goes up and down, y equals a number, that is our horizontal line here. It is the opposite of what you expect it to be. We have two more cases as well. We have the y equals x. That means we're starting at the origin and has a slope of 1, so we're counting up 1 over 1, and it's a line that goes straight up and down with a slope of 1. And the other would be y equals negative x. So this one here would start at the origin, and we can go down one to the right one or up and to the left. It has that slope of -1, so that downwards line going to there. Those are probably the most difficult ones, and we're not going to go any further than that. We won't do anything such as y equals 2x plus 3 or as a line of reflection. We will be keeping it as y equals x or y equals negative x unless it was a bonus. So let's take a look at some examples. So let's say we have the point 3, 4 reflecting across the line y equals 1. So what we want to do is graph that out. So here's our point 3, 4, and here is our line of reflection, y is equal to 1. So we want to make sure that we're doing a perpendicular bisector. That's what y equals 1 needs to be to go from P to P prime. So we had to take note of how far away is P from that line of reflection. If we were to draw a perpendicular line straight down, we can see that this is 3 units away. So that means P prime has to also be 3 units away going in the exact same direction. So this would be our new point here, which is 3, -2. Let's take another look at another example. If we were to plot these 3 points, -3, 4, 0, 1, and 4, 2, we would get a graph that looks like this. Now we're going to reflect this one across the y-axis. So here's the y-axis. You can tell so because that's the origin. And I want you to take note here how this is going straight through our pre-image. So something special happens there. So what we're going to do is determine what our other points are going to be. So it's a matter of counting how far away they are. So such as this one is 3 units away. In order to reflect it, it has to go 3 units in the opposite direction. Same thing with C and B. So this would be your location for A prime. As you can see, once again, B was on the line of reflection, so it's going to end up being itself. And C was 1, 2, 3, 4 units away, so C prime is going to be 4 units in the opposite direction. And then what we're going to do is connect those points. So if A prime, B prime, and C prime. And I want to point out something very special here. Do you see how in the original picture, right here, okay, we had our line of reflection going right over our pre-image. If that ever happens, it goes right in the middle like that, you can automatically assume that when you do your image, it's going to do the same thing. And we can expect an overlap of our image and our pre-image. So now let's take a look at one more example. we have a triangle with the vertices F, G, and H. So what we're going to do first are plot those points. So we have the points 3, 2, 1, 5, and negative 1, 2. And what we're going to do is label those as F, G, and H. And then from there, we're going to connect the points. And I want you to kind of take notice here, we're labeling it with just F, G, and H because it is just the pre-image. So what we're going to do now is first redo the first reflection, which is y equals x. So if I draw my line y equals x, now I need to determine where the next couple points are. Well, the way that we kind of do this is let's kind of take a look and see how far away is this line going to be so it's perpendicular to the other line. Well, in order to be perpendicular, it has to go the exact opposite. So we're looking at a line that's going like this. Okay, on the diagonal with a slope of -1. So this is kind of like a half a box away from where our line is. So what I'm going to do is when I plot my other point, I want to make sure it is also essentially like a half a box away from there. So now when I go for this one is exactly 1, 2 lines away from there. Do you see that? How it goes 1, 2 boxes away. So we're going to do the same thing here. We're going to count 1, 2 boxes, and that's where our next point is going to be. And for H, this is essentially like 1.5. So if I count 1.5 going the opposite direction, it's going to land right here. Now these are F prime, G prime, and H prime. So we have to make sure we're labeling those with the correct stuff. So now we're going to reflect it over x equals -3, which is a line that goes up and down just like this. And we're going to now go the perpendicular, which is the exact opposite in this direction here. So again, I'm going to count over 1, 2, 3, 4 for G, 5 for F, and 5 for H, and then go the exact opposite on the other side. So 5 for F, 4 for G, and 5 for H. And what you'll see here is I'm going to label these as F double prime, G double prime, and H double prime. And that would be your final image. As always, if you have any questions, please make sure you bring them tomorrow and that you do the completion form found after the video. I'll see you tomorrow.